Hello and welcome to today's webinar about the Squish GUI Tester 6.4 feature, the script-based object map. Thanks for joining today. My name is Florian Turk. I'm a technical sales engineer with FrogLogic, and together with me, Nico Kaufmann is hosting this webinar, who is the lead developer of the script-based object map feature. So he can give you technical insights on the new feature. I will give you a short overview of the agenda for today's webinar. I'll give a short introduction of our company. I will give you an idea of the Squish GUI testing tool itself for those who have not tried it before. After that, I'll hand over to Nico to let him show you the feature itself and give you some theoretical introduction to it and give you a live demo to it. We'll have time for questions and, of course, answers as well at the end of this session. You are muted, but you have the chance to post your questions into the GoToWebinar client. So you can just post your questions. We won't answer them immediately. Instead, we just collect them until the end. And so thanks a lot for understanding that you won't get an immediate answer, but we won't forget your questions at all. All right, so let's start then. First of all, some facts about FrogLogic itself. So the company has been founded in 2003. We are based in Hamburg, Germany, where most of the people working for FrogLogic are located. We also got a US presence, which opened in 2009, and some people working around the globe, but the development and also most of the support work happens here in our Hamburg offices. The company is focused on software testing, on quality in software testing, and we have two products, two main products. First of all, the Squish GUI Tester, which is what this webinar is about. But we also have Squish Coco, which is a code coverage analysis tool, which I would like to have at least mentioned. So that gives you an idea about how much of your application source code is actually executed when running tests. And it can be used together with Squish or together with your unit tests. Might be interesting for one or the other who does not know about it. All right, so that's FrogLogic. Squish itself is, or the Squish GUI tester itself is used by a large number of companies which are located all around the world. You can see some of our customers on this slide. You will notice bigger companies here. The smaller ones are typically not mentioned, but there are many, many small companies using Squish as well. And those companies are from all kinds of industries. And Squish is a very generic GUI test automation tool. So it can be used to automate applications of many different kinds. And the reason for that is, first of all, that it is a cross-platform testing tool. So you can use it to automate your desktop applications running different operating systems. But we also have Squish for mobile to test iOS and Android applications, and we are capable of testing embedded applications which might be based on operating system like QNX or VxWorks or simply embedded Linux. Squish supports a wide range of toolkits and technologies. There's a list down here. I won't go into the details today because we are talking about a different topic today, which applies to all the different editions. But we get support for all the different toolkits, which can be mixed. And if you want to learn more about that, we got plenty of information on our website. We got frequent webinars on the single Squish editions covering different toolkits, which are also listed on our website. Yeah, but let's have a quick overview of the Squish features before I hand over to Nico. Yeah, first of all, Squish comes with a behavior-driven development and testing feature, which allows you to specify your test in a very abstract way, so that technical people as well as non-technical people are able to understand your test and are also able to create new tests without the need to have programming knowledge. That is done by using the capture and playback approach. So what does it mean? It means that you can just use your application from within Squish in a recording, and Squish will simply record all the user interaction and create a test out of that, which you can finally play back. So up to that point, no scripting is actually needed. Of course, GUI testing is not only about automating an application, it's also about verifications and validations. So making sure that correct values are displayed by your application and that the application actually does what you're expecting it to do. And that is done through verification points. So that's how we call it in Squish. And there are different kinds of verifications, simple ones, which can check for the text of a specific object, like a label. And there are more complex ones, like screenshot verifications or visual verifications, which are actually checking a subtree of the application's object tree, including screenshots and internal properties. We get a powerful test creation environment, which allows you to do all the things which I've just mentioned, and that also includes the scripting functionality. So underneath the behavior-driven development and testing layer, we got the option for a number of scripting languages. We got support for Python, Perl, Tcl, Ruby, and JavaScript. And yeah, this is the area which this webinar will be about, in addition to the object recognition, because the new feature will use the scripting language to specify the objects, the object names in a different way than before. Yeah, we got data-driven testing in Squish, so you can include your Excel spreadsheets or other comma or tab separated data files and let them drive your test executions and use the data as input. And the architecture of Squish allows you to do that in a distributed approach. So remote testing is something which Squish supports in a very flexible way. So you can test on your local workstation machine, you can test desktop applications, but of course you can also test embedded applications running on the device. I mentioned Squish for iOS and Android. We support testing on the device itself, and we also support virtual machines, of course. So the architecture allows all of that. The integration is quite easy. So the tool itself has many open interfaces. So we get command line tools, which you can simply use to integrate Squish into your existing systems. But you can also use one of the plugins which we offer, which exists for many tools, including the popular ones like the Jenkins CI server, Atlassian Bamboo. We get integrations for bigger application lifecycle management tools like Rational Quality Manager or Quality Center from HP. So there's a lot you can benefit from, which is also listed in our documentation and on the website. So, but those are topics which we won't focus on today. Instead, we will focus on the new feature, the script-based object map. And this is the point where I will hand over to my colleague Nico. Just a second, I will make him the presenter and make sure that you're able to hear him. And yeah, hello, Nico, are you there? Can you hear us?
Yeah, welcome to the technical introduction to the script-based object map. My name is Nico Kaufmann and I help develop the script-based object map. So hopefully I can answer all the questions you might have. I want to start by giving you a short overview of this introduction. As you can see on the outline, first I want to shortly talk about why to use object maps at all. What is the general advantage? And I want to show you an example of text-based object maps, which has been the default for the last few years. And then I want to introduce you to script-based object maps and show you what has changed compared to text-based object maps and show you the basic structure and start talking about the advantages of this new approach. So after that, I will give you a brief overview on how to convert text-based object maps to script-based object maps, introduce you to our very basic conversion utility, and try to show you some of the challenges you should expect when you try to convert your existing test suites to the script-based object map. Then I'm going to show you how well the script-based object map integrates into the IDE, how we adapted existing features to the scripted object map, and how you can use new features like renaming and reference finding to help you maintain and write test scripts. And at last, I'm going to show you some advanced examples on how to best use the script-based object map to reduce redundancy, split object maps, and in general just unleash the power of the script languages to improve your object maps. So let's first talk about why use object maps at all. So using object maps will make the maintenance of your test scripts easier so that when your AOT changes, in most cases, you only need to adapt your object map. So let me explain that in more detail. When you want to automate graphical user interfaces, in order to test them, you need to somehow identify the buttons and controls you're going to automate. And this is usually accomplished by a set of properties that uniquely identify those controls you want to automate. In Squish, this is what real names are for. And let me just really quick show you what I mean by that. So this is the wrong example. I prepared an example suite. And this entire webinar will always use this suite. And this is what you probably, if you've used Squish before, this probably looks familiar. This is simply using our example application and just creates an entry in an address book. And well, the first thing it does is clicks on the new button, and to identify it, this is the real name we use. And in the real name, you can see the properties that we use to identify the button. And we use the text property, the type property, and the window property mainly to identify this button. And in theory, you could just use real names all over the place, and every single instruction could simply just use the real name. But during the development of your AOT, the identifying properties of a button or control will most likely change many times, which would then mean that every time a button or control gets moved or renamed, you would have to adjust all your test scripts to that reference that one button. And this is where the object map comes in. It provides another layer of indirection by assigning symbolic names to real names. So by using symbolic names in your test scripts, you can avoid having to adjust them when the UI changes. And this is what you can see here. Those are the symbolic names that basically point to the object map. And inside the object map, you will find the real name behind it. And so if the real name changes, you only need to adjust the object map. And while this approach already works quite well, we felt like it can still be improved. If you look at this test script, you can see that the symbolic names and real names are all strings, and this makes it quite hard for the editor to do anything with it, since determining if this is a string, that maybe it's some string from your application that you want to verify, or is it a symbolic name, or is it a real name? It's actually not trivial, and it's really hard for us to provide you with proper refactoring or with auto-completion. And also, it's also hard for you if you want to use parameters with your names. It's really, you have to concatenate strings, and it's really difficult. And those are the areas that we want to improve with the script-based object map. So let's talk about script-based object map. Let me first show you a comparison. So let's have a look at this side-by-side comparison. On the left side, we see the text-based suite we just saw with symbolic names as strings. You see here, and on the right side, we see the symbolic names have become variables in the script module. In this case, names is the module, and address book new Q2 button is a variable inside that script module that now holds the property information. And this will give you auto-completion, refactoring capabilities, and will enable a lot more functionality. So let me show that in the script, in the editor. So here we have this same suite, it does the same thing, just this is a scripted version. And if I now remove this button, and you can see that the IDE gives me an auto-completion. I can easily select symbolic names now, and I can even writing scripts from scratch has become a lot easier now. And what you can also do is you can use refactoring capabilities like renaming. So since this is a auto-generated name, it's not very good. So let's just rename this to new button, and you can even preview the changes that are going to be made. One is of course a test script, the other is the scripted object map itself, and we can just confirm this here, and you can see that it got renamed properly. And let's now have a look at the script-based object map itself. So with the text-based object map, I would expect that most users only interacted with the object map editor instead of actually modifying the file. And with the script-based object map, you can still use the editor. So if I click this, it still shows me the object map here. But the map itself is now stored in the script module, and I would encourage you to consider making changes to the script module itself, because that will enable you to benefit from the script-based object map even more. So this is a scripted object map, and obviously every script language will look a little bit different, so we try to keep them as similar as possible though. In this webinar, however, I will focus on Python, and here we have a script-based object map in Python. So let's talk about the structure a little bit. On the top you see this object map helper include. This is basically used for wildcards and regular expressions, so it's nothing you have to worry about. It will just be auto-generated, and the important part is down here. Then those assignments here. On the left you see the symbolic name, or what has previously been the symbolic name, which we could now call a scripted symbolic name. And on the right here we have what was previously the real name, which is now a scripted real name. And so you can see that real names are now actual dictionaries, which gives us proper syntax highlighting, for example. And also it's much easier to add parameters now, or to dynamically change values in it, since the script language actually knows what to do with it, not only the IDE. And let's just, one thing that's really helpful already is if you have a mistake in it and you mistype, chances are very good that the IDE will help you and tell you that there is actually an error here, as you can see now. And if we go back to the old object map, you can see we have a very similar situation here, except for that this is just a string. And if I make any mistakes here, you can see the editor doesn't know this is a mistake. And so you can spend a lot of time finding this particular error now. Yeah. What else do I want to show you? Yeah, while we are here in the script-based object map, I can quickly show you how to add wildcards now. For this, we would have this script object instance, which is actually located in the object map helper, and this would now basically be the same as a wildcard. Of course, if you go into this module, you can see that there's actually just two script objects defined in it. That's the entire reason this, or almost the entire reason this object map helper even exists. But there's another way to do the same thing. I mean, first maybe we should try if this still executes. Yeah, it does. But let me show you a different way to do the same thing. If you go back to the object map names file and we remove this change again, I can also just go like you might be used to it. If you have used Squish before, you can simply still go here and change this. And if you save it, you'll see get a refactoring dialog. And I would encourage you, whenever you encounter one of those refactoring dialogues, really look at the changes that are being made. Most of them will be correct and kind of smart, but some of them might be incorrect. So be sure to always look at this. And if you confirm it, the change will be written into the script file. So you don't have to remember this wildcard and regular expression stuff. You can simply use the editor for it. Yeah, so this is the basic structure. And as you can see already with the editor and refactoring dialog, we try to keep workflows from the text-based object map working with the script-based object map as well. But even with the change we just applied, you can see that this file really is just a recorded scripted object map, and it's really not really optimized yet. It's not really easy to look at. But what you can do with the script-based object map is you can use all the features your script language offers you to improve the object map and make it more maintainable. A first example of this is that you could add functions to the script-based object map. So if we look at this a little bit closer, we, for example, see that we have a tool button here and we have a tool button here, and they share so many properties. Like the only thing that really changes is the text property and the window. So what we can do here is we just go ahead and define a function. So I can define this tool button function, and it gets the text parameter and the window parameter, since that's the only thing that really changes. And let's just copy the name. And let's add this as a parameter. And you can see, in the old text-based object map, you would have needed to, do some string operations, and it would have been really cumbersome. But here you can just really easy replace these parameters. And yeah, let's see if we add this function now. We can also make use of the auto-completion now, I hope. So, and we are already done. And now we can do the same for this button. Maybe just copy this. And this is supposed to be add. So let's see if this works. Still executes, still finds the buttons. And also if I go into the editor, you can see that it still lists these properties. And yeah, I will give you some more examples like this later on. For now, let's move on to the conversion. So after we had a first look at a script-based object map, I want to take a look at how you could approach converting existing text-based object maps to script-based object maps. We decided to implement a very basic conversion mechanism that can help you with some of the tedious grunt work, but will most likely require some manual work as well, since the way you might be using symbolic names and real names in your test scripts might actually be quite complex. And yeah, we can't really do anything to really reliably convert that. We decided to just support the most basic use cases. So let's look at the dialog. So if you have a text-based object map like this, you can find it either in the object map itself. There's a button here to convert it, but there's also a button in the suite settings. And let me just open the dialog. So yeah, this dialog will give you two options. The first one is copy and convert. This will keep the original suite and make a copy before converting it. And I would really recommend you to use this option. The other is to replace it in, convert it in place. So this will override the existing suite. And while it's possible to review all the changes made later in the process, I wouldn't really suggest using this. I mean, maybe if you use Git or SVN, then you can still try this one. Furthermore, as you can see, we made sure to include this information text here to make sure everyone who uses this understands that the conversion isn't perfect, and you might have to apply manual changes to make the converted suites work. We included a link here to the documentation where you can read up on some of the common problems. So let me just look at the first problem here. For example, we don't really look at real names at all. So we just look through the script and see if we can find symbolic names, and we replace symbolic names. And this is what would happen now if you use such a real name in your string. Chances are the symbolic name gets replaced, and that breaks the text-based real name. And so that would be something you would have to fix manually. So this is the kind of issues you can expect. So yeah, let's just go ahead and convert this now. So here I can give a new name for the converted suite. So let's call it converted2. And in the next step, I will be able to review the changes. Yeah, here I can see what will be converted. For one, we create a scripted object map, and this will most likely be correct. So this can already help you a lot. This is probably not something. This is something you will have to work through again, but it will execute. Then the last point here you see it gives you the option to delete the object map, the old text-based object maps. And I just want to mention that it's entirely possible to use the old map and the new script-based object map side by side. Maybe during the migration process for a short while you want to use both. But you just have to be aware that if you record new scripts with the old text-based object map still intact, it will reuse some of the names in the old text-based object map. So just be aware of that. But if you want to ease your migration, you can just not delete this and just continue to use it. And what you really have to pay attention to is the script changes. And as you can see, I already replaced the real name here, and we run into exactly the problem I just described here with the real name. So the symbolic names get replaced correctly, as you can see here, but this real name gets a little bit destroyed. I will still select this change. I could just not apply this change, but let's just apply it anyway. And have a look at the result. So if we look at the script now, you see this is a little bit broken. I mean, I could see this, I could execute it and notice, but let's just remove this for now and use auto-completion and see if this now executes correctly. And it does. So yeah, let's have another look at the converted object names file. It's basically the same as the recorded one, except for the order. It's a little bit different when you convert it. To sum up this conversion, so the conversion of the object map itself, as I already said, should be correct and work just fine. So you should definitely be able to use the resulting name script module and save a lot of work there. But the resulting script files might need some review, since we really only do a search and replace there. But I would take these challenges as an opportunity to really improve your object map, because the areas where the conversion falls short are actually the areas where the scripted object map is really strong, and you can bring a lot of the improvement and stability to your test script. So all the places where you have custom real name handling can probably be brought back into the scripted object map using functions and making the code much more reliable after you've adapted it. So I would really embrace these challenges. So let's look at the next topic, IDE integration. Yeah, we already looked at some of the examples of how we integrated the new script-based object map into the IDE. But let's have a more detailed look now on the different functions. So one was auto-completion. I already talked about it a lot. This obviously can now help you to write scripts manually. So it's gotten much easier to write scripts freehand, so to say. So since you don't have to look up symbolic names anymore, you can just easily modify your test scripts now. Then we have go to definition, which is also really helpful. If you press F3, you instantly can see how a scripted symbolic name is defined. And yeah, this obviously also works from within the scripted object map itself. You know, if you have references inside the scripted object map, you can easily jump to the definition. And what you can also do is find references. So if, for example, I want to find out where this symbolic name is used, I can simply go to the refactoring menu and do find all occurrences. And it will then show me all occurrences inside the scripted object map, as well as all test cases that use this scripted symbolic name. And yeah, this I think is also really helpful to know if the symbolic name is still used and in what context it's used. So this will already help a lot with maintenance of test scripts and finding out, you know, how to improve the scripted object map. And then yeah, I already showed you renaming. Oh, one thing I missed about the find references. In Python you will find it here. But in other languages like JavaScript, you will find a references menu here. There's actually two options. One only includes references and one also includes the definition. Yeah, renaming. I already showed that you can rename scripted symbolic names from basically anywhere. And the big advantage here is that really all occurrences get renamed too. So if you, for example, if you, for example, were to rename the add dialog, you would see here in this preview, you can already see that many occurrences are renamed. So this will be very helpful. You can reach this by either pressing Alt-Shift-R or you can find it in the refactoring menu. So yeah. Now let's talk about how IDE features specific to the text-based object map transfer over to the script-based object map. So I already talked a little about the object map editor. It will continue to work for the script-based object map in most cases. It actually shows an interpreted version of the scripted object map file, the script module. So in some cases, especially when you edit a lot of logic to the script-based object map, what is displayed might be slightly different from what actually is in the file. But even if it differs a little, you can still make changes, and in most cases that will work just fine. When you save the changes, that actually creates the refactoring, which I already showed you, which you will be able to review and see if the change that is made will be correct. I will show you this what I mean by this right now. Let's just look at, for example, I think I edited this right. Did I add a function here? Yeah, we have a function here now, and the function is assigned to the new button. So let's go into this view. We see we still have the new button, and we can still change the text, for example. But what happens now is that since the object map editor uses an interpreted version, it actually reads the result from tool button, and it doesn't really know that this is a function. So it just says, oh, I have to replace this entire function. I mean, the good thing is the resulting name will still be correct. So this script, I mean, if the change itself is correct, of course, new isn't a correct change, but if it were a correct change, it would still be usable. And so we really try to balance this out so you can still make use of the editor, especially if I change any other name here, as you can see, those changes would still be correct, and you don't have to throw away your function definitions. You can also uncheck specific changes here, so I can just uncheck all changes in regards of this, and then only get the correct change. So yeah, that's why you have to be careful with refactoring dialogues, but in general, we always try to somehow get a smart decision on what to change and what not to change. Yeah, since the object map editor still works, you can also still do things like open symbolic name. So this will still work and take you to the name in the editor, other than the go-to definition, of course. It really depends on which editor you want to use, but I would really recommend to go for the text version. Yeah, and of course, what also works is convert to real name. So, but in this case, it will not convert this to a text-based real name, but it will now convert it to a script-based real name, to a dictionary, basically. Yeah, that will also work. But I want to stress that how this workflow of converting to real names is really not necessary anymore, because with the scripted object map, those references here are essentially real names already. So you can do this, everything you can do with a real name, you can also do with this reference. And so I would forget about this entire function. So it's really just there to make the transition easier, but in the end, you will probably not need it really. Yeah. So now I think I can continue with the advanced examples. So I prepared 2 example suits here. And this is basically still the same suit from before. I took the same recording. It still does the same thing. But I really worked on the scripted object map to make it less redundant. So let's first have a look maybe at the old version. Okay, this is not entirely the initial version, but it still works to prove my point. As you can see, for example, we have a lot of redundancy here, unnamed, visible. Those properties are used all over the place, and it really clutters up the vision, and you can't really make out which attributes are actually important here. And so I worked a little bit on this. And if we open the redundancy example here, you can see that, first of all, I added a lot of functions here, but you can already see that, for example, there's just one place where I need to really mention this, and everything else just is generated out of that. And while at first it might look like, there's much more text here, if you look at the actual names, this is got really reduced, and you can already much better see through this and understand how each button is defined here. And you can imagine the more controls and buttons you click and include into your scripted object map, the more benefits you are going to get if you use this more, or let's call it heavily scripted variant. And what I did here basically is to extend the scripted real names here, the dictionaries. I use this merge function. In other languages, it might be a little bit easier to merge dictionaries. I think Python 2.7 doesn't really have a good merging function. So this just takes two dictionaries and makes them into one. So that a window is basically a widget and also has a window title. And a widget is then just, has a type, is unnamed, invisible. And this isn't like the best practice, but it certainly is better than not doing it. And you will have to find out for yourself what you think is useful, really. What I did here, for example, I think it would already help if you don't have this entire, it would already help to just have a function for each control type. And this would already be a big improvement, I think. If you don't necessarily have to go the route of merging different dictionaries, but whenever you do change a dictionary or like a scripted real name, I would always do something like a merge. I think that's the most sensible thing to do, I guess, in this case. And yeah, of course, it also, has become much easier now to just guess how to introduce new names. If I wanted to use the open button, I could just probably do something like this. Or in window, yeah. And then if I go back to the script, do we have the script somewhere? And maybe at the end, I want to click the button, the open button. Without really looking up the name of the button, it will just work. As you can see, it clicked the open button at the end. So this is the one benefit, and I want to show you another example, which is splitting of object maps. Again, I used the same suite as a basis, and what I did now is I split up the map based on the screens, or I have the main application and I have a dialog. So in the main application, I keep all the controls that are really linked to the main window. And you can see it this way it gets even more easy to look at and to automate. And yeah, I think this will already be much easier to maintain. And if you look at the dialog, we have all those labels and line edits here, and the dialog itself, and this one button, and yeah. And all the functions I put into separate module, so they don't clutter up the view there. And yeah, one important thing I want to mention here is that you always need a names.py. So this is really like the root file that is always called. But from there on, you can then include other files. And those files actually here, the main application and dialog and basic controls, I could have also put them in the global scripts directory and share them between different test suites. And another thing I want to show you here is that you can still use the editor. It still shows you the hierarchy. And of course, you will run into trouble again if you now change this, but it will actually be at least kind of sensible what it creates. So it will find the correct file and it will make a correct change here. Even though, of course, the function is replaced, but it's still kind of sensible what it does here. Yeah, I think that's about it. Florian, do you want to take over again?
Yes, so yeah, thanks Nico for your presentation of this new feature. I think it comes with a lot of things which will be quite useful and improve the way you can organize your object names and object recognition in general. So yeah, so we are right in the question and answers part, and yeah, there are only few questions. The last one, which I haven't answered yet, is will the examples from today's webinar be made available for download from your website? Nico, I guess you can provide the attendees with this, right? So I can send the link later on.
Yeah, we can send the link later on, yeah.
Okay, all right. There's one other yeah, feature specific question which was I will just read it. If the name of an object is changed in the object map, is the name refactored in all of the scripts that use that object, or do we have to change the name scripts manually? Basically, of course, we have this refactoring feature which Nico presented. So that will do the job. It will change the occurrence in the object map file, but also in the script file. So you have to use the refactoring approach, and then it will be fine, and it will change all occurrences. Okay, so if there aren't any other questions, I think we're pretty much done. I'll just take another look at the list, but no new question. Yeah, we also recorded the webinar, so we will publish a link to the recording if you just want to forward that to someone else who could not attend that webinar today. Feel free yeah, to forward it. Nico, something else from your side to add?
No, I'm done.
Okay, so yeah, thanks a lot for your attention. Thanks a lot for attending. We would be happy to hear back from you. If there are any questions following up after this webinar, feel free to get in contact with us. You can always reach us at squish@froglogic.com. We're also on Facebook, Twitter, and stuff like that. So if you prefer that. And yeah, other than that, we get frequent webinars on different topics every week. So check back our homepage to get the list of upcoming webinars. And yeah, once again, thanks a lot for attending the webinar. Have a nice day. Bye-bye.
Bye-bye.